Hakuna Matata 4.5, AAS and ASA. These are two more ways to show that two triangles are congruent. So that's what we're going to add to our list. First we had side, 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 and then we had side, angle, side. And so these are two more ways. Let's go ahead and look at those ways. The first one, angle, side, angle postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So basically, it's talking about two angles. It's talking about two angles and the side in between them. And it's important. If you have the two angles, the side has to be in between them. Okay? And then the other postulate is angle, angle, side. If two angles and a non-included side of one triangle are congruent to two angles and a corresponding non-included side of a second triangle, then the two triangles are congruent. So it turns out that if there's two angles, it doesn't have to be always the side in between them. It could be a side that's not in between them as well. All right, so there it is. We have four ways to show that two triangles are congruent. So let's take a look at a few examples. Like this yellow one and this pink one. Is there enough information to show that these two triangles are congruent? Let's look. We have the 90 degrees. That's one angle. We have the side that is marked. So we have a side. And then we have an angle that is marked. So yes, these two triangles are congruent because of angle, side, angle. All right, so that's how you do those. Notice that the side is in between the two angles, just like this side is in between the two angles. All right, let's do another example. Congruent or not. Looks like we have an angle, and then this one, only one of the angles is marked, but you should know that if one side is 90 degrees, the other one also has to be 90 degrees because they are a linear pair, and linear pairs are supplementary. So that one you can mark in yourself. That's 90 degrees. That makes another angle. And then there's actually one more thing you are allowed to mark. It's the side that they share. So they share a side, so you can mark that as well. And it turns out that these two triangles are congruent because of angle, angle, side. Angle, angle, side. Sometimes they take the two triangles and they push them together to make the picture a little bit confusing. So to make it less confusing, you can pull the two triangles apart, kind of like this. And then we can look. Well, this angle was here, side, and then this side was here. So far we have a side. This angle is 90 degrees and this angle is 90 degrees, so we have an angle. And then, if you remember from the original picture, they share a side. So when they share a side, you can mark it. So it turns out that this side is congruent to this side. And yes, these two triangles are congruent because of side, angle, side. And then sometimes, I think the next part of the homework, they're going to ask you, what's missing to make angle, angle, side work. Well, so far we have an angle with this angle. We have a side with this side. So we need another angle. So which angle is the correct one to mark to make angle side work? It turns out that this is the angle that we need to mark. B and K. Okay, so B and K are the angles we need to mark to make it work for angle side. If you were to mark angle C and J, that wouldn't work for angle side, but it would work for angle side angle. All right, so you just have to know the order does matter. All right, our first proof for the day. Let's go ahead and take a look at it. They tell you the given CB right down the middle bisects angle ABD. So it bisects this big angle, and it also bisects ACD. It also bisects that big angle. Now, the word bisect is very important. You should know that when you bisect something, it cuts it exactly in half. All right, so let's go ahead and try our proof. The first step is pretty easy. Just rewrite the given. Notice I only wrote part of the given, and you'll see why in a little bit. CB bisects angle ABD. All right, so CB bisects angle ABD. So it cuts this angle in half. It bisects that angle. That is given to us. So what can we conclude then? If it cuts this big angle in half, then it turns out that these two angles are going to be the same now. Because you got the big angle, you're going to cut it in half, so it creates two smaller equal angles. So angle ABC, this one, is now congruent to angle DBC, this one. And how do we know that? It's just the definition of what a bisector does. It cuts something in half. All right, I'm going to write the other given now. CB bisects angle ACD, so it cuts this in half. That was the given, and then same thing, if it cuts it in half, then it forms these two angles that are equal. Angle ACB is congruent to angle DCB. Those are equal. Same reason, a definition of a bisector. So far we have this angle is congruent to this angle, and we have this angle is congruent to that angle. So we have an angle here, we have an angle over here. Is there anything else we can have? I mean, we've used up all the given, and it looks like CB is equal to CB. It's the side that they share. When you say something is equal to itself, we call that reflexive. But now we were able to find a side that works. And so I think that's enough information to show that triangle ABC is congruent to triangle DBC. And those two are equal because of angle side angle. All right, so that's how the proof is going to work. Let's go ahead and try one more. All right, let's do one last proof for the day. As you can see, this one's going to be kind of a long one, so try to follow along. But it's long because there's lots of given. They tell you that C is the midpoint of BE, that's one given. They also tell you that AB is perpendicular to AD, that's two givens. And they also tell you that DE is perpendicular to AD. So they give you three pieces of information. So you're going to have to use those three pieces of information to show that these two triangles are congruent. All right, so let's go ahead and let's start off with one of the givens. C is the midpoint of BE. So here's C. It is the middle of BE. So that is the given. But what does that mean? If C is the middle, then it should create two equal pieces. What are the two equal pieces? BC should equal EC. That's the middle, and that's because that's what a midpoint does. It just creates two equal pieces. All right, so we were able to show that this side is equal to this side. Now careful, it doesn't say anything about AD, so it does not cut AD in half. The given only said that it cut BE in half, so don't use the AD. All right, so I think we were able to find one side. Next, there's the other given. AB is perpendicular to AD. All right, that was given to us. So AB is perpendicular to AD. What does that mean about this corner? Perpendicular means it'll make angle A 90 degrees. Definition of what perpendicular means. Here's the other given. DE is perpendicular to AD. So what does that mean about this corner? Angle D. It means angle D is also 90 degrees. The definition of what perpendicular means. All right, so now we actually have to say it. So if angle A is 90 degrees and angle D is 90 degrees, if we just took out the 90 degrees altogether, we can just say that angle A is equal to angle D. And do you guys remember what that was called? The transitive property. All right, so there it is. We got an angle. So I'll actually write it here. Angle. We had side right here. All right, so we need one more thing. Can you guys think of anything else that we can prove? We've used all the givens. If you can look at the picture, you can see the angle ACB, this angle right here, is equal to DCE, this angle right here. Do you know why? They are vertical angles. All right, so we were able to find an angle. So now we have enough information to show that triangle ABC is equal to triangle DEC. All right, and now our job is to figure out the order. And it looks like we have angle, angle, side. There it is, angle, angle, side. Okay, again, these proofs are not meant to be easy, or even how would you come up with 9 steps all on your own. It's not easy to come up with all those steps, but we're going to practice all these proofs to maybe so that you can get used to proving these shapes. But that is all we have for today, so go ahead and try your homework.